as I promised you, I am going to put all of the most useful rules of log into one collection for you. I'll explain it to you, and I make this set of rules available as one handout on my site. You can buy clicking on the link of it, download it, and have it on the side of your workings. But also maybe by referring to them in the numbers that I've used on the side of each rule. Maybe so when we, for example, doing a question and I'm using perhaps rule number 3, I would say to you, I'm going to use number 3, and that way you know where we're getting our rules from. So let's begin from the very core rule, the main concept of logs. As you remember, I am very specific about using the log and writing it in a very specific way. So the font for the subject of log is bigger than the base that we use, and the way we read it, we would say log of a to the base b, and log of a to the base b, if it's equal to an answer, that is equivalent to an exponential, and this exponential is related to each other in this way, that a, which was the subject of the log, is equal to the base of the log to the power, which is the answer of the function of log working on a. So, and also I remember that I specifically in the previous video said to you that there is a cycle between these. So if you notice that the exponential is actually written in this way, that the base b to the power of n should be equal to the content or the subject of the log. Okay, so let's move on to the rules. So rule number one says that if in the subject of log you have two subjects multiplied by one another, so we are doing log of a multiplied by b to the base b, then you can actually write that as two separate logs, two individual logs, with each subject separated in each log. So it would be log of a to the base b plus log of b to the base b. Sometimes you might have that situation and you revert it to this, or you have this and you revert to that, depending on situation and depending which one will work for us better. So that's a two-way rule. If you have the two content, if you got the two contents divided by one another, so you have log of a, which is divided by b, so these two subjects are divided by one another, the base b, that can be written as two separate logs subtracted from one another in that order. So log of a, which was the numerator here, minus log of b, which was the denominator. So again, that works in both ways. A very useful one that often is used is rule number 3. Rule number 3 is log of a, which is a subject, but to the power of n. And so that's really a. So it's like a being multiplied by itself, that many number, to the base b, and the power can be brought out as a coefficient outside the log. So it will become n times log of a to the base b. So this is actually a reusage of this rule, because here, instead of having a times b, you have a times a times a times a times. So you will have so many a's multiplied. So you would get log of a plus log of a plus log of a plus log of a. So you get so many of them added together, which then you can say, I've got that many of those logs. and then the power, instead of being on the subject, in the next rule, if the power is, instead of being on the subject, if the power is on the base, then it still comes out as a coefficient, but it would be a reciprocated coefficient. So instead of being n times log of, it would be 1 over n. So for example, if that power was 3, then you get a third multiplied by log of a to the base b. This is also a useful rule. It's obviously not as useful as the rules up to number 4. So I've organized them in the way that they're more used in solving questions. This is also useful, that if you have 1 over, so in fact if the log is not in the numerator but in the denominator, so if you got a reciprocated log basically, so if you got 1 over log of a to the base b, that is equivalent to log of b now being the subject and a now being the base. So basically the place of the subject and base has been changed, so that it's no longer in the denominator. So this is probably sometimes easier to work with, because having a situation when log is in a denominator, it will create a fraction that will be difficult to work with. So avoiding having a fraction in our question, we could simply just change the place of the base and the subject, and there's no fraction anymore. It's just one single log. And finally, this is probably very rarely used, but finally, if you got a division, of a log of a being the subject to the base b, divided by log of, so this is actually a log divided by log. It's not subjects, so it's not like this where the subjects were divided by one another. This is in fact a full log divided by another log. And so subject A base B, subject B base B, and the final result of that would be that A would be the subject of this log, and the subject of the log in the denominator will become the base of this log. So it merges it into one log, which is again often a useful thing. If you got too many logs and it's possible that you get it in this situation, then you can make one single log out of it. These 6 rules are the most common rules that you will come across, but let me write this in different colors. So you know that log of a to the base a is 1. So that's not a rule really. This is a common sense. So because a to the power of 1 is a. So that's often a useful thing to know. And you also should know that log of 1 to any base is 0, and that's simply because b, a number, to the power of 0. So anything really to the power of 0 is equal to 1. So these two sometimes come into use, but they're not really rules. It's just a matter of knowing how indices works. Logs cannot have a negative subject. We will explain that when we're talking about the graphs of logs. But just remember that logs cannot have a negative subject. Okay, I'm going to close the lesson here with this, but in the future lessons, we will work with these rules. So there will be examples that I will work through, and I post them as I make them. I try to use questions where my students have come to some difficulty with them. So it's not only doing a question, but we do questions where have caused issues with other students. So it will be a good source for you to use. If you wanted to write this, I'm sure you could write this during the you had time to write it during the this video. I would also save it in a document, and I would put it on my site so you can pick it up from there. But practice them. They're very, when you look at them, they're very logical. There isn't, there seems to be a theme that goes on here, and they're quite logical. So practice them a couple of times. There's not that many of them. And if you practice them on a piece of paper, and if you need to kind of confirm that you have done the right thing, you can maybe come back to the source and look to see if you have written them right. But if by the time you've done 4 or 5 of these and a couple of times, it becomes a very logical theme of thought that you will not forget. One thing you have to remember is that the pattern has to be exactly like these. So, so if you have a number here, for example, so if you look at it, there is no number written here, there is no number written there. So, don't make something up. Follow these, and if they are not exactly in this form, then of course there is another rule that you can use to bring it to this form, and then you can use the rule itself. So don't make things up. Stick to these rules, but it could be, for example, in a question that a couple of these rules, or maybe more than a couple of these rules, are working together. So you have to use one to reach the other stage, and then from the other stage to move on. But don't make them up. These are the ones that you have to be using. Okay, I'll see you in the next video.